Okay, so it's 2 p.m. Welcome everyone for our second webinar in this series we are doing about Kubernetes. Today we'll have Thomas presenting the Kubernetes cluster autoscaling and some of the work we've done internally. So if you have any questions during the presentation, just raise your hand or write it in the Q&A part, and we'll pick it up as we go, or we can also have a discussion and take questions also at the end. So I'll pass to Thomas. Thomas, go ahead.
Hello, everyone. Today's session is about Kubernetes cluster autoscaling. I'm Thomas Hartland. I'm a member of the cloud team here at CERN, and part of my work is working on the cluster autoscaler, and in particular, how it interacts with OpenStack. So you could say I'm reasonably knowledgeable about the internals of the cluster autoscaler, but we won't be going that in depth today. This will just be an overview of why you would want to use cluster autoscaling and then how you can use it. And as for why you would want to use it, cluster autoscaling allows you to avoid answering a difficult question, and that question is, how many nodes should I have in my cluster? Because the answer to that question is, you should have just the right number of nodes, not too many and not too few. And of course, that isn't really helpful at all, because the right number of nodes is not so easy to determine. For a number of reasons, it depends on a lot of factors, and if you are deploying a production service onto a Kubernetes cluster, you will probably go through a bit of a trial and error period of changing the number of resources allocated per pod, changing the number of pods. And this, of course, affects how many nodes you are going to need. And even then, once you've settled on a right number of nodes, that number of nodes is going to need to change over time. And I mean this both in the long term, as your service grows and gains more users, you're going to need more cluster capacity to handle that workload. But then also in the short term, if your service depends on the number of active users, then you may well see a day-night cycle of high load in the daytime, and then over the nighttime when everybody is asleep, you'll see not very much load at all. And so you do not need as many nodes in the cluster. And this is something maybe we don't think about too much in our own private cloud, but if you're running Kubernetes on a public cloud, then you are paying overnight per second for those resources that you are not using, and you should really do something about that. And what you should probably not do about that is wake up first thing in the morning and scale the cluster up and scale the cluster down just before bedtime. That's not a good idea. Instead, you would entrust this to the cluster autoscaler. So this is a component that runs in your cluster. It monitors the pods and the nodes of the cluster and continuously reevaluates, do we need more nodes? And if so, it talks to the cloud that it is running in and requests more nodes for the cluster. Could nodes be removed without impacting the service, or is it about right? And that's really the core logic of the autoscaler. If there are pending pods that cannot be scheduled because there is not enough room in the cluster, then scale the cluster up. On the other hand, if there are nodes that are empty, scale the cluster down. And on the surface, it's that simple. Behind the scenes, it is more complex. It's running a full simulation of the Kubernetes scheduling process to ensure that it is making the right decision. Because even if a pod might fit onto a node in terms of number of resources, there are other reasons why it might not. That might be, for example, a pod anti-affinity rule that prevents it from being scheduled onto that node. And on the scaling down side, it tries to be a bit clever as well. And it can, if it sees a node that has some pods on it, but not many, then it can see if it will help by moving those pods onto other nodes to make sure that the node is empty and that it can be removed, to ensure that you get as close to the lowest number of nodes as possible. And so you see pods are the driving force behind the cluster autoscaler's decision making. And so one common way to use this is alongside pod autoscaling. So this is a feature of Kubernetes that will try to match the number of pods in a deployment to the workload that deployment is handling. So this could be trying to maintain 80% CPU usage across all pods, or it could be something more complex, like trying to ensure that each pod is only handling a certain number of requests per second. And we will go probably more in depth into this in another webinar later on, but I will not be going too much into this today, and I will not be using pod autoscaling in my examples, just because for a demonstration, it's easier to scale the deployment manually. But this is what you would want to be using for a production service. And so that just about covers the why you would want to use cluster autoscaling. Now let's take a look at how you can use it. First, with how to deploy. So on OpenStack, this is part of the cluster create command. You give the name of the cluster template, whichever labels you want to pass in addition to the template, and then the important ones, autoscaling enabled true, and then a minimum node count and a maximum node count. And the autoscaler will ensure that the cluster is restricted to be within these node counts. So it's important especially to set a sensible value for the maximum node count so that you are not, say, overflowing the project quota. And now we'll move on to a demo. I say here, let's deploy a cluster, but I have actually already done this. I've deployed several clusters already for today. So let's move on and try and trigger a scale up. So let's take a look at what we have in this cluster. See, we have, to begin with, no pods. And we have two nodes, one master node, and then one worker node, which is where we will be deploying our pods. And you can see that the cluster autoscaler is already running here. You can see that its pod is running in kube system, and we can check the configuration for this by editing its deployment. And you can see what is important here is this configuration where it says here's the 1 and the 4. This is the minimum node count and maximum node count, and this is what you would want to change if you were going to reconfigure this for a different range of nodes. And there are also some extra configuration options here that you might be interested in. So this is the scale down delays. This controls how active the cluster will be in trying to scale down. So by default, only after a node has been completely unused for 10 minutes will the autoscaler try to remove it. And you can make this more or less responsive depending on what your requirements are. Okay, so now let's get some pods into this cluster. So I'm going to be using a simple Nginx deployment, and this will be the same across all of my examples. I'm going to be requesting 400 milli CPUs per pod, and this means that I will be able to fit 4 pods onto each node. That's going to be the same throughout all of the examples. So let's first deploy this. You can see we now have the 1 pod creating, and let's scale up. First to 4 nodes. And you can see we can get 4 nodes per pod. 4 nodes per pod? No, 4 pods per node. That's it. So they're now all running. But if we scale up just by 1 more pod, you'll see this pod is pending. It's pending because there is no space for it to run in the cluster, and it will stay pending. But the autoscaler has seen this pod, it's pending, there's no space for it to run in the cluster. That is the requirement to trigger a scale up. And we can verify that this has happened by looking at the kube system namespace a config map called cluster info. This isn't what I was expecting. Describe config map cluster autoscaler status. That's what I was looking for. And so you can see here, 53 seconds ago, scale up, setting group size to 2. So it is adding 1 more node for us, but our pod is still waiting, and we are still waiting. This is a live demonstration. We don't want to wait. The pod waiting, however, is worse because a node can take 5 to 10 minutes to appear in the cluster. That's a long time. 10 minutes is a long time for a pod. Really, it should be starting instantly. And so we can do something about that. We want to get the pod running as soon as possible. And if there was already an extra node waiting, that would be enough for it to be able to run instantly. So we want to have the right number of nodes in our cluster, plus 1, just to give us a bit of extra space to grow into. Unfortunately, there is nothing in the cluster autoscaler that will do this. It's just not possible, because if there was an extra empty node in the cluster, it would want to remove it. So we need to put something in the space of that extra node we want. And we can do that with a kind of a buffer deployment that will reserve this space for us and then give us back that space as soon as it is needed. And this can be done with Kubernetes pod priorities. So by default, every pod will have a priority of 0. And we can instead make a deployment that has pods with negative priority, so that when an actual pod comes along that we want to be scheduled, like this Nginx pod, the scheduler will see that the more important pod should be scheduled, and it will terminate one of the buffer pods to make the room. So we can see how that might look in another cluster I have. So in this cluster, I already have 2 nodes, node 0 and node 1. And for the pods, you can see I have 4 Nginx pods running on node 0 and 4 buffer pods running on node 1. And if you take a look at the buffer pod deployment, it's exactly the same, except it is specifying this priority class name buffer. And I have created this with buffer priority class. It's a priority class with a value of -5. So this time, when we scale up the Nginx deployment, to 5 replicas, what we we see happening instantly is that a buffer pod has been terminated, and that has been replaced by a pending buffer pod. And there is also this pending Nginx pod. Because of pod priority, the Nginx pod will be able to run in the space on this node that has been created. And it is the buffer pod that is now in pending and waiting. So we'll see again we're scaling up to 3, but it is the buffer pod that has to wait for that node. The Nginx pod was able to start running immediately. And so that is how we can efficiently scale up our service without having to wait for this new node to be added. As for what you can run in the buffer pod, either you can find something that you just need yourself that can be done in a low priority pod that might be killed at any time. Or if you want to, you could run Folding at Home or Boink or any of these volunteer computing resource type of applications. And that will be a more efficient use of the space in your cluster. But that has actually left some more empty space in our cluster, because now, let me jump back into a different cluster which has finished this scale up that I just initiated. So you see now we have the 3 nodes. So node 2 is the one that was just added. And if we look at the pods, we see, yep, we have 5 Nginx pods, 4 on node 0, 1 on node 1. The 3 buffer pods still on node 1. And then the 1 extra buffer pod that got moved, which is now on node 2. But on node 2, we only have 1 pod. It is 3/4 empty. So can we do something with the extra space on that node without accidentally triggering another scale up and without getting in the way of our Nginx pod? And the answer to that is yes, we can. It this time involves playing again with pod priority and how the cluster autoscaler sees that. So the autoscaler will ignore below a certain priority. By default, that is -10. So we can use that to our advantage by creating a deployment that will scale, that will run whenever there is empty space. But as soon as that space is needed, the pods will go back to pending, but those pending pods will not trigger a scale up. So let's see that in action here. So let's see. So this is going to be backfilling the empty space in this cluster. So I have a backfill priority class with a value of -15. That's less than -10. So that satisfies the cluster autoscaler. It will not try to autoscale for this deployment. Let's apply that priority class. And then we have a deployment, this time using the backfill priority class. And so, not this, this. When we apply this backfill deployment, you'll see we fill up 3 of the 3 remaining slots on node 2. So node 2 is now full, and we have this 1 extra backfill pod that is pending. It won't be able to run, but it will also not trigger a scale up. So you see here, events, none. It's not going to do anything for that pod. And scheduling is something to consider for efficient autoscaling. To be efficiently running on the lowest number of nodes possible, you would prefer to always schedule onto the node that is already most used. In Kubernetes, the default is to do not that, it is to spread across all nodes as evenly as possible. And this can be changed in the Kubernetes scheduler configuration. And I will show you this that we have in our documentation for configuring the kube scheduler to accept some different scheduling priorities. And so this policy that you can apply to it will, instead of prioritizing the least requested node, will prioritize the most requested node with a weight that makes this the highest priority. So that, and this is especially useful if you have something where pods are being continuously created and destroyed, because they will eventually all converge onto the smallest set of nodes possible. If you have very long running pods, then this won't be as useful. And because of what I said earlier about the cluster autoscaler trying to move pods where possible, that doesn't really work in conjunction with the scheduling priorities, because ideally you would already be scheduling onto the smallest possible number of nodes, so you wouldn't need to forcefully make that happen. But if you definitely do not want a pod to be moved by the autoscaler, then you can add this annotation to it, either in the deployment spec, pod spec, or in a job, or however you're creating your pods, that says it is not safe to evict. And you can also ensure the safety of a node by annotating it with this scale down disabled true. And that is what you would want to do if you were using a node for ingress, or if you had other external references to the IP address of this node, because then you would definitely not want that node to disappear. Another use for cluster autoscaling, even if you don't need to change the number of nodes in your cluster, is to have it auto heal your cluster. So let's say you've decided on the right number of nodes for your cluster, and you've decided that that's 5. You're fully utilizing all of those nodes. You know it doesn't need to be changed. You're not pod autoscaling. If you enable the cluster autoscaler with a minimum of 5 nodes and a maximum of 6, then if one node breaks or becomes unhealthy, the pods will be removed from that node, will go into a pending state, and then the cluster autoscaler will activate, will add a new node, and then remove the unhealthy one. And so I have an example for this as well, which is here. So you see in this cluster, I'm not doing it with 5 nodes, but I have 2 nodes. I have 4 pods on each node, so 8 in total. And if I drain one of these nodes, it will, oh, cannot delete pods with local storage. All right, let's delete pods with local storage. So we've deleted these. I shouldn't have done node 0. I should have done node 1. That's why pods at local storage. Okay, that's fine. We've evicted these pods. So they are now pending. And of course that means the cluster autoscaler has seen that and has scaled up. Once that new node is ready, these pods will then move to that node. And after however long the cluster autoscaler waits, this was the scale down before, This is the delay before scaling down. The default was 10 minutes. It will remove the unhealthy node because there are no longer any pods running on it. So now, that's everything that I wanted to say about what you can do with cluster autoscaling at the moment. There is more that I haven't mentioned, but now I want to talk about the future, what is coming. So in the next couple of months, we will hopefully have support for Magnum node groups in the cluster autoscaler. And with this, we will get node group auto discovery, which will make configuring the maximum and minimum node counts per node group much easier. You shouldn't need to change the cluster autoscaler pod configuration. You should just be able to leave it running, and you can change these things on the OpenStack side. And this future is coming very soon. I have just this week got my pull request made for supporting this. Hopefully we can get this reviewed, and it should be merged in time for Kubernetes 1.19. And so that will be our next Kubernetes release here. And then we can start using this. And I can give you an exclusive preview of what this will be like. So let's go take a look. So first things to notice is that in the configuration of the autoscaler, it's much the same, only we don't specify the minimum and maximum node group, the minimum and maximum number of nodes here. We say we're using node group auto discovery, and it will select all node groups with the role auto scaling. And so if we go and we take a look at our node groups, it's this cluster, OpenStack COE node group list for this cluster. You can see I've already created several node groups. So there are the default master and default worker node groups. Then I've also created node group 1 and node group 2, which both have this role auto-scaling that the cluster autoscaler is looking for. But it is not auto-scaling them just yet. So if I show you the cluster autoscaler status, you see there is not as much information here as before. And that's because it is not actually scaling any node groups right now. You can see it gives a cluster overview, but here where it should be listing node groups, it is not. And the reason for that is that we haven't set the maximum node group count for these node groups. By default, there is no maximum, but for cluster autoscaling, it needs to be set. So this is quite an unwieldy command, but we'll go for it. Node group update with this cluster and this node group. We will replace max node count, and we'll set this one to 3. Okay, that's good. And then for node group 2, let's set that to 4. And the autoscaler will pick up these changes. So let's go and let's watch this status. And oh, it's already got them. It can take a bit for it to see these changes, but it has already picked these up. So it's now giving us both the cluster-wide status and the status of these two node groups, node group 1 and node group 2. And let's now put some pods into this cluster. And so I've prepared an Nginx deployment here that will specifically select being on node group 1. So if I apply this, you see that it is creating, and it has selected this node, demo 0 node group. Okay, it got cut off, but it's running on node group 1. And if we scale this up, deployment nginx node group 1 to take more than one node. So let's put it to 6. Obviously, there is enough space in the cluster because there are, that's not what I wanted to do. There are 3 nodes that it could run on, but because we're specifically selecting node group 1, there is at the moment only 1 node. So 2 of these pods are going to be stuck in pending. And the cluster autoscaler has seen that. It knows that these pods can only be scheduled on node group 1. And so it is specifically scaled up node group 1 to a size of 2. Okay, so that's it for this demo. Actually, one more thing we can see in node groups here. This is node group 1. We can see that it's a scale up in progress. There is 1 node ready already in the cluster. And for the cloud provider, the target number of nodes is 2. So that's what it is scaling to. And you can also see it here. It's picked up the maximum size of 3 for this node group and the maximum size 4 we said for node group 2. Okay, so now I am done with this demo. Let's go back to the slides. And we can look at this now. And I encourage you to look at it in your own time if you're going to be using the cluster autoscaler, which is the frequently asked questions page. There is a lot of information here, more than you could read in the time of a webinar. So that's why I encourage you to look at it yourself, and particularly to look at the configuration options that there are. So this is how you can configure how reactive the autoscaler is to pods or empty nodes. You can configure more limits. The maximum number of cores across all node groups is one thing. So that would be maybe something that you would add for if you specifically wanted to not go above the number of cores allocated in your project quota. And there's a lot of stuff here. So that now brings me to the end. And there haven't been any questions asked yet, so I assume that you're all saving them right for this moment.
Awesome. Thank you so much, Thomas. This was brilliant. Does anyone have some questions already or any inquiry? Don't see any hands. So I have one question on the min max. So how do you, when you create a node group, is it possible to pass min max at creation time also instead of replacing like you did?
Yes, that is possible.
Okay.
Both the minimum and the maximum. I'd quite like to, at some time in the future, make this easier, because the replace command is a bit, it's not great to use. So I'd like to make that easier somehow.
Okay, there is a question from Richard. Richard, I'll give you the ability to speak, so you can just unmute and ask yourself if you want. Yeah, go for it. Okay, I can't hear Richard though. I see he's unmuted though. Maybe I just ask it. So the question was, is the autoscaler now aware of available OpenStack quota?
It is still not aware of the quota, which is why you should be setting the maximum node counts to a sensible value, but it is no longer as, okay, so before, the reason why this was important is that if you hit the quota, the cluster would go into a failed state and the autoscaler would not be able to recover from that. Now, if you try to exceed the quota, nodes will fail to be created, and the cluster autoscaler will see that, and it will back off from trying to scale that node group up again, and it will take care of the nodes that failed. So in some ways, yes, it is aware, but only once it has tried to exceed the quota.
Okay, thanks. There's another question from Marcus. Marcus, feel free to unmute and ask directly.
Hello over there, Marcos here. So I have a question about the pod affinity. I know that maybe it's not very close to the topic today, but you know, we can configure pod affinity in the deployments as you showed before. At least from experience, could be a bit complicated to configure. Moreover, when you have several services deployed in the cluster. So my question for you, would you recommend the usage of pod affinity for the auto scaling, or just the usual metrics to put like 400 millicores and all the stuff? Thank you.
Okay, they're kind of unrelated. You should always be setting the resource requests and limits for your pods. That's something you should always be doing. And for pod affinity, that's what you should be using if you want to either guarantee that you're running on separate nodes and so that you have a highly available service, or if there is another reason why they should be running on different nodes. That might be depending on, you know, hardware or something like that. You know, if you can only use one GPU per node, you can only have one pod per node. So I'm not sure.
Okay, thank you. No, I think
has anything to do with
my question.
autoscaling. Okay.
Thank you.
Okay, so any other questions? Feel free to jump in. Otherwise, well, thanks a lot, Thomas. This was super interesting.
Okay,
and
you're welcome.
I guess if anyone has questions, you know where to ask them directly as well. And we can always do like an update later in this series if we think we can do a more in-depth update on some particular feature if there's interest.
Okay.
Cool.
All right. So thanks for joining, everyone.